Hello and welcome everyone. Today we are covering an exciting topic in machine learning. We will build a spam classifier machine learning model. We will ingest a dataset. I have this dataset open in Excel. It has about 5,700 records, and the column B tells us whether the message is ham or spam. 1 is spam and 0 equals ham. We will read this file and use this file to train and test our model. Once the model is ready, we can use it to make predictions. Let me give you a preview of how the model can be utilized. I'll grab the first email and provide it to our model. The model is behind this web application. The model will predict whether the given message is ham or spam. I'll hit classify and the model predicts that this message is spam. I will go back and grab another message. This time I will select a ham message, copy it and provide it to the model. I will hit classify to see the model prediction. This message is ham. So based on the data, we train our model and then use it to make future predictions. The end goal is to have a model that we can run against an actual inbox and filter out spam emails. For example, let's say we have a Gmail account with thousands of emails, and this model can run through these messages and either save them to a spam folder or simply delete the messages. I'll show you a practical example of how we can use this machine learning model in real life. Let's switch over to Jupyter Notebook and see how we built a spam classifier with Python. I have my Jupyter Notebook open. This notebook is available on GitHub. Link is in the description below. We are importing the required libraries at the top. We'll be using pandas for data import, model selection from sklearn to split the data into two categories, train and test. Then we'll make use of Count Vectorizer from sklearn to convert the words into individual features. I have example down below on this. Also from sklearn, we are importing the Naïve Bayes multinomial model. Naïve Bayes classifier is a probabilistic machine learning model that's used for classification tasks. We will use word cloud to see the frequently occurring words in our data. Finally, we'll use Pickle to export the model for future use. In the next video, we'll see how to use the model we built today to classify email in an inbox. I'll run the cell to import the libraries. You can run the cell with keyboard shortcut Shift plus Enter or from the toolbar above. We will read our data with pandas read CSV method and provide it the file location. It is in the current directory within a folder called data. This file along with notebook is available on the GitHub repo. Link is in the description below. We are printing the first 5 rows to look at our data set. We have a text column containing the email body and a spam column with the value of 0 and 1 describing whether the email is ham or spam. 0 means it's a ham, an actual message, and 1 means it's a spam email. Let's group the data frame by spam column to see the split between ham and spam messages. We have 4360 valid emails and 1368 spam messages. Let's build a word cloud to see the frequently appearing words in our dataset. I will run the cell to update the word cloud. Since each message begins with the word subject, it has the bigger font size, followed by will be and click here and free. These are the other most common words. You can explore this dataset further to get familiar with it. To test and train our model, we'll split the data into train and test dataset. The rule of thumb is to have 75 to 80% of data for training and remaining 20 to 25% for testing. Selection of this 75% of data is random. We are using the train test split. We imported this from sklearn at the top, and we are supplying this function with our data frame column df.text and df.spam. And we are specifying the test size of 25%. So the remaining 75% of data will be used for training. I'll run the cell to split the dataset. The multinomial machine learning model works with numeric data. Our text column in the data frame contains text as is. We need to come up with a method to convert this to numeric. so it is compatible with the format expected by the model. This would be challenging if we were to perform this manually, but we already have a library called Count Vectorizer that automates this process. I have an example of Count Vectorizer, what it does and how it works. We have a corpus variable. Corpus simply means dictionary or all the words in our dataset. Let's assume we have these 4 documents, and these are all the words in these documents. We want to convert these words to a matrix of numbers, ones and zeros. We initialize the count vectorizer, and from the vectorizer we call the fit transform and provided all the words in our dataset. This converts each unique word into a feature, in other words, into a column. In this example, we have 9 unique words. Each of these 9 words are treated as a column. Once we call the array on the transformed data, it prints a matrix of ones and zeros. Let's go over this matrix. It will check in the first document the first word, which is and, to see if it exists in this document. And in this case, it does not. So it puts a 0 for it. Does this word exist in the second document? No, 0 again. Does it exist in the third document? Yes, and it puts a 1 there. Let's go to the second word, document. Does it exist in the first document? Yes. In the second? Yes. It occurs twice in the second document, so we see a 2. And it doesn't exist in the third document, and it exists in the fourth. Each word is converted into a feature, and we pass these converted features to the machine learning model. Let's go ahead and call the count vectorizer to convert our words into a matrix of features. We will call the fit transform and pass it the xtrain values. It converts our text to a numeric, and we can see few of these features. There are a lot more, but not all of the features are displayed here. We have a dataset now that is compatible with the machine learning model. We will initialize the multinomial NB model from sklearn and save it as a variable called model. This model will take the count of each word, and it will predict the label ham or spam. We are calling the model.fit and passing it the xtrain count and the ytrain. Our model is trained on this data. We can test it by providing it a simple message and see what prediction it makes. Count Vectorizer takes an array, so we are providing a message in the email variable. We are transforming it through the Count Vectorizer and saving it into a variable called email count. We call the model.predict and supply it the email count variable. The result is saved in test variable. If it is 0, then it is ham, and 1 is spam. This message is, as it turns out, is spam. I'll grab a ham message from the dataset to test. I'll paste the message. We have apostrophes in the string, so I'll go ahead and fix this issue by adding another single quote. I'll rerun the cell. The model classifies this message as ham. So here we go. This is our model. It is trained on the data, and we can use it to predict. We can get the accuracy of our model from the model.score. We convert our x test to numeric and pass it to the model.score along with y test. Our model score is very high. It is 991, which means this model will produce accurate results. Okay, we have built, test, and train our model. Now it's ready to do the work. We are going to export Count Vectorizer. This will convert the data for us in the future, and we will use pickle to do the work. Also, we are going to export the model to the disk. We can import these 2 files in our application and use them to classify email messages. I am using these 2 files in the Streamlit application that you saw in the beginning to classify the text in the text box. Once I click on the button, it passes the text to the vectorizer and then calls the model to classify the text. But in the next video, we'll see how to use the model that we have generated against an actual inbox to filter out the email messages. If you like the content, give it a thumbs up, like, and subscribe. Take care of yourself, and I'll see you in the next video.